In the following movie, we'll open up a CAD-neutral step file, create a finite element model from it, and then process a change from an updated CAD-neutral step file. We'll begin by creating our finite element model in the Nastran solver environment. We'll next wavelength the body that we're going to create our finite element model of. This is important so that we can use some wave functionality later to allow us to process the change in a semi-automatic manner. We'll begin by creating our mesh on the geometry. We'll also put a mesh control on one of the faces to refine the mesh locally. Next, we'll put some constraints on the model. We'll also apply that to geometry. And we'll put a load also based on the geometry. Now that we've prepared our finite element model, we'll go ahead and open up the changed step file. Here there are some geometric differences between the original and the file that we just imported. And in order to update our finite element model, what we need to do is bring in the changed model, and here we'll be able to see some of the differences more plainly, and then use the replacement assistant that's part of the wave functionality in order to reassociate the faces and edges from the original to the changed part. Now there's a number of matching algorithms that we can use. One of them is the geometric, and here we just used that and matched 145 edges and faces from the original to the updated part, those edges and faces that did not change. Now there's some other algorithms that are available as well, which can use attributes, or you can manually select the current object and then the replacement object, which is what we're doing here. So we need to do that on only the faces that did not get matched automatically. And it's also not necessary to do it on all faces, but it is necessary to do it on the faces that have objects that are associated to them in the related finite element model. So now that we've identified which faces map to which other faces, now we can go back to our finite element model and update our mesh. And what you'll notice is that that mesh control that we had put on that face stays associated with that face, so we maintain that mesh control, as well as the loads and boundary conditions that we applied and associated to the geometry.